Hello everyone and welcome back. Today we'll be solving another question called prime summation. Here is the question. At the end of every mathematics class, Arif's teacher used to give him an integer n and told him to count the prime numbers in the range from 3 to n inclusive, which can be expressed as the sum of consecutive prime numbers. For example, 5, which is a summation of 2 plus 3, 10, which is summation of 2 plus 3 plus 5. 58 is a summation of 2 plus 3 plus 7 plus 5 plus 11 plus 13 and plus 17. Arif has not completed any task for the T days and he is in trouble as he will not have to submit all his tasks tomorrow. Help Arif to finish his task. You will be provided with the number n for each day. So we just have to tell the count that how many numbers are there, how many prime numbers exist in the range of 3 to n, such that you will always find a consecutive sum of prime numbers resultant to another prime number. So we have just seen the example. Let's take a look at the inputs. So if there is 17 as an input, so there's a range between 3 to 17. There are only two numbers, that is 5 and 17, which is 2 plus 3 and 2 plus 3 plus 5 plus 7. And when there's the range is 50, there's also third number, which is 41, which will result when you sum it up 11 plus 13 plus 17. Yeah, or yes, exactly. So all we need to do is always just go ahead and find those number. Let me write this question over here. So you will be given a range of n. Here are inputs. So from 3 to n, find the prime number p such that it's going to the p of some other p1 plus p2, so on other prime numbers. Okay, it will result into a prime number. So all this should be consecutive numbers. So that's all. One condition is that I'll give you guys a quick thinking pause so that you can go ahead and think about how we can solve this question. Post, I will continue and I'll talk how I will be solving this question. Okay, so let's get back. Well, I will come up with some very fancy algorithm or a solution. Rather, I will just stick to the basics and I will just follow the instructions. So the here given instructions are that you need to get a prime number who's always going to sum of other prime numbers, right? So you need to find some n prime numbers who's going to return you this. So first of all, I'll create a set of prime numbers. So how am I going to create the set of prime numbers is most efficient way. So the most efficient way is we have this algorithm called Steve of Erothesis, which will help us in calculating, pre-calculating and storing all the prime numbers, okay, for a very large integer. And then simply I will just start from the initial number and I'll check that is that any moment in time I will receive a number x. If yes, well and good. If not, I will just stop and break the loop then and there. So two parts. First is like create all the prime numbers, pre-calculate the prime numbers. And then second is loop and check if you can actually create or not, if you can get a prime number p or no with the summations. So this is what I'm going to do. So how I'm going to pre-calculate is with the Steve of Erothesis. So the how Steve of Erothesis works is like you create a big prime numbers list chunk. So let me draw this for us. Here's how you initially create and initially put everyone as true. So that means that you initially say all of these numbers are my prime numbers. Okay, I'll quickly give indices values. So these are indices of 0, 1, 2, 3, 4, 5 and 6 and 7. After that, what I'll do is I'll start iterating from 2. Okay, and I'll update the very first two elements saying that they are false. This and this is false. So after that, I'll start from 2 and I'll say that for each of these multiples, they are not prime numbers, because we know if 2 is a prime number, the multiples of 2 are never going to be the prime number. And I will do this for a very long. So I'll have a variable called max. So I'll do all this. I'll initialize my array to the max. with trues, and then I will iterate this values of f 2 till the max. So I'll take 2 and I'll say false, and 2 twos are 4, which is false, 2 twos are 8, which is going to be here false. So on and so forth, you make all of this guys false, 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 and then I'll start with 3. Whoever element which is true, I'll again pick that element and I'll go on and so forth and do add false. So I'll go 3, 3 to just 6. So 6 is false. Again, 3 threes are 8, 3 threes are 9. I'll make this guy false. So it's 8 and 9 here. So I make this false. Again, I take 10. So again, next element would be 5. Again, this is a prime number and I'll make all of its multiples as false. So on and so forth, you continue this job and you will only leave left off with the true elements which are actually prime numbers. So this is a prime number, this is a prime number, here you have a prime number, here you have a prime number. So this is how the step of erothesis works. So once you pre-calculate all of these numbers with this true and false values, then you just have to loop through all of these elements and say that first of all I'll try for 2 to get a summation. You can't because there's no prime number before that. Again, you start for 3. But since you have only 2, so you can't. So can you go for 5? Then they have two possibilities, 2 plus 3. So you say, yes, I have a counter. You put a counter, you increment a counter. So the moment you get this, you increment a counter. And then you do that till the range of n. So we are given an n, right? From 3 to n. So you do that and then print the count. That's all, folks. It's just following the instructions and nothing fancy. The only optimization what you can do is rather than going to the default way of generating or finding a prime number or not, we can pre-calculate and save it. So let's do some coding. I will first pre-calculate and put our values. As I said, I'll initially make the 0 and the first prime as 0, 0, and then I'll start my P at 0th index. So we just make it false. I think this is unused value. Just remove that. Yeah, that's all. Now we'll go back to our main function. We will first call our helper function, which will pre-calculate. Post that I'm going to take the input t, number of test cases, and we will do the work for all of that. So initially I'll have a count c and a x which starts from 2. If that particular number is a prime, only then I'll go ahead and I'll add the value to it. And if my x is greater than the number, I just stop there and I say I break it. If the given current x is also a prime, that means you have reached a number which is prime by the summation of all the prime numbers, which is also the requirement. So in that case, I'll just go ahead and increment my x. And once this for loop is done, I will simply come out and I'll say see out my value. Let's try running the code. As expected, it's 2 and 3. Let's try submitting the code and see if it's working for the rest of the test cases. Accepted. So a quick summary to the question. Here you need to count the number of prime numbers which are also the resultant of some n consecutive number submissions. Okay, so what we do is we start always from 2 and then first of all, first step is that we find all the predefined, we pre-calculate the prime numbers with the help of step of erothesis. That is the most accurate way of finding the prime numbers. Post that, you just loop through and you check. You start from 2 all the time and then you go ahead and you check if any point in time you get a x or the sum, current sum, which is also prime. If it is, you go ahead and you increment your counter, and if not, and if your current sum is greater than the number, then you stop. So that's all, folks. Thank you so much.